day everyone. So today I will discuss about ratio and proportion. Ratio. A ratio is a relationship between two numbers of the same kind. The quantitative relation between two amounts or quantities usually indicated as quotient of two mathematical expressions. How to write a ratio? We can use colon and writing a ratio. We can also write ratio in the fraction form. We can also use the word to. Antecedent and consequent. Antecedent. Ante, which means before, is the first term in ratio. Consequent is the second term in ratio. P over Q, P is to Q, P is to Q, where P is the antecedent and Q is the consequent. Always remember that the first term or the P here is the antecedent and the Q or the second term is the consequent. Here are some examples. 4 is to 3. 4 is the antecedent and 3 is the consequent. 5 over 8. 5 is the antecedent and 8 is the consequent. 7 is to 9. 7 is the antecedent and 9 is the consequent. Proportion. It is the equality of two or more ratios. Relationship between two things when quantities of two are equal in ratios. Two ratios that have been set equal to each other. Equation that can be solved. Here are examples of proportion. 4 is to 8 is equal to 3 is to 6. 12 is to 3 is equal to 16 is to 4. 5 is to 10 is equal to 4 is to 8. 9 is to 18 is equal to 1 is to 9. And 8 is to 4 is equal to 6 to 14. Ratio versus proportion. Let us compare ratio and proportion. Ratio is one thing compared to or related to another thing. It is just a statement or an expression. Ratio is made up of two numbers, while a proportion is two ratios that have been set equal to each other or equation that can be solved. Proportion compares two ratios. Means and extremes. Means are the inside term. It is from French, from Latin, medius, which means middle. Extremes are the outside term. Comes from the Latin word extremus, meaning outside or outermost. A is to B is equal to C is to D, where B and C are the means and A and B are the extremes. For quantities A, B, C are said to be proportion if A is to B is equal to C is to D. The product of extreme is equal to the product of mean. So AB, which is the product of extreme, is equal to the product of mean, which is C. Continued proportion, in which the consequent of each ratio is the antecedent of the next. As 2 is to 4 is equal to 4 is to 8 is equal to 8 is to 16. Three numbers A, B, and C are said to be continued proportion if A, B, and C are in proportion. Thus, if A, B, and C are in proportion, that means that A is to B is equal to B is to C. The product of extremes is equal to the product of means. Mean proportional. It is also called the geometric mean. Of two positive numbers A and B, if the positive number x such that A over x is equal to x over b, when solving x is equal to the square root of A times b. To calculate the proportional mean of a continued proportion, extract the square root from the product of the extremes. So 3 is equal to x over 12, x squared is equal to 3 times 12, so x is equal to 16. Third proportional of two numbers a and b is defined to be that number c such that a is to b is equal to b is to c. So you want to find a number a and c such that 12 is to 18 is equal to 18 is to c. That number or the c is 27. Fourth proportional is any of the terms of a ratio 2 over x is equal to 4 over 10, x is equal to 2 times 10 over 4, so x is equal to 5. X over 5 is equal to 4 over 10, x is equal to 5 times 4 over 10, so the x is 2. Always remember that three quantities are said to be in continued proportion if the ratio of the first and the second is equal to the ratio of the second and the third. B is called the mean proportion between A and C is called the third proportional to A and B. That's all.
After discussing the basics about ratio proportion, we will now proceed to a problem involving how to find the fourth proportion. So we have here x squared minus 5x plus 6 all over x squared minus x minus 2 is equal to x squared plus 4x plus 3 all over unknown quantity. In order for us to find the unknown quantity, first we have to factor out the given product. Factoring the given products resulted in x minus 3 times x minus 2 all over x minus 2 times x plus 1 is equal to x plus 3 times x plus 1 all over unknown quantity. Next, after factoring the given products, we will now proceed to the cancellation of the singular terms. X plus 1 is similar to x plus 1, then x minus 2 is similar to x minus 2. After cancelling the similar terms, we will now proceed to multiplying the left terms, which is x minus 3 multiplied by x plus 3. X minus 3 multiplied by x plus 3 will result to x squared minus 9, which is the fourth proportional. So the final answer is x squared minus 5x plus 6 all over x squared minus x minus 2 is equal to x squared plus 4x plus 3 all over x squared minus 9. That's all.
So the next topic that I will discuss is about the property of trapezoid. But first, let us know what trapezoid is. Trapezoid, a quadrilateral, sometimes also known as tetragon or quadrangle, is a four-sided polygon. Let us focus on the property 6 of trapezoid, which states that the diagonals can be found using the sides of the trapezoid. The length of the diagonals are E is equal to the square root of AB squared minus A squared B minus AC squared plus BD squared all over B minus A. Q is equal to the square root of AB squared minus A squared B minus AB squared plus BC squared all over B minus A, where A and B are the bases, C and D are the other two sides, and A is less than B. This is the problem. You are asked to find the diagonals P and Q. Q. Same thing go with this. Q is equal to the square root of AB squared minus A squared minus AD squared plus BC squared all over B minus A. Q is equal to 3 times 6 squared minus 3 squared times 6 minus 3 times 10 squared plus 6 times 12 all over 6 minus 3. So 108 minus 54 minus 300 plus 864 all over 3 is 618 all over 3. So Q is equal to the square root of 206. Always remember to put the radical sign. It is very important. Very, very important. So, we are asked to find the length of the diagonals P and Q. So, in order for us to get the length of the diagonals, we need to find the length of the sides of the trapezoid, which are already given in the problem. So as I said a while ago that the sides are already given, let us proceed to this formula. P is equal to the square root of AB squared minus A squared minus AC squared plus BB squared all over B minus A. So A is equal to 3, B is equal to 6, C is equal to 12, and D is equal to 10. So P is equal to the square root of 3 times 6 squared minus 3 squared times 6 minus 3 times 12 squared plus 6 times 10 squared all over 6 minus 3. So 108 minus 54 minus 482 plus 600 all over 3. 222 all over 3. So P is equal to 74.
Let's have a short discussion about the special lines in a triangle. An angle bisector is a line or ray that divides an angle into two congruent angles. In geometry, a median of a triangle is the line segment joining a vertex to the midpoint of the segment. Altitude of a triangle is a line segment through a vertex and perpendicular to a line to the vertex. In a triangle, the segment joining the midpoints of any two sides will be parallel to the third side and half its mid-segment. A mid-segment of a triangle is a segment that connects the midpoint of two sides of a triangle. Midpoint is the exact middle point. It means middle, halfway point, midway point, and also it is a point somewhere in the middle. For example, let's have this example for the mid-segment theorem. Here, P is the midpoint of AB and Q is the midpoint of BC. So, PQ is a mid-segment. Therefore, by the triangle mid-segment theorem, PQ is equal to 1/2 BC. Substituting the values, x is equal to 1/2 multiplied by 6. X is equal to 3. The value of x is 2. Therefore, the mid-segment is half of the measure of the third side. As a conclusion, if the midpoints of any two sides of a triangle are joined by a segment, then that segment is parallel to the third side and half its length. That's all. Line triangles. Principle 8 states that the altitude to the hypotenuse of a right triangle divides it into two triangles which are similar to the cube triangle into each other. This states, for example, triangle BAC is divided by line segment BD. According to Principle 8, the altitude to the hypotenuse of a right triangle divides it into two triangles which is triangle BDC and triangle BDA. This means that line segment AD over line segment DB is equal to line segment BD over line segment DC, which also means that BD is the geometric mean between AD and DC, or BD is equal to the square root of AD multiplied by DC. BD is equal to the square root of AD multiplied by DC is stated by corollary 1, which states that the length of the altitude drawn to the hypotenuse of a right triangle is the geometric mean between the length